Hello and welcome. Today we're going to continue our discussion on rational exponents. I introduced this to you in our last lesson when we talked about simplifying radicals, and we're just going to go a little bit more in depth in it today. First, I'd like to recall simplifying radicals. Step 1 is always to identify the index. So in this first one, square root of 20, my index is 2. Anytime there's not an index written, we assume it's a 2. Step 2, we factor the radicand completely. The radicand is the number inside the radical, so in this case it's a 20. When I factor, I find the prime factors are 2, 2, and 5. Step 3, we make groups of the factors. The groups must be the size of the index. So when I look at my factors, I'm looking for groups of 2. I see 2 2's as my factors. So what this tells me is I can bring one 2 out to the front of my radical to represent this group, but anything that didn't group up must remain underneath the radical. So I still have a square root of 5. So the simplified form of my radical is 2 square root of 5. Down below, I first identify my index, which is 3, and then I factor my radicand completely. 8 factors into the prime factors of 2, 2, and 2, and my y to the fourth factors into y times y times y times y. I then look at these prime factors and make groups of 3 since my index is 3. I see a group of 3 2's, so I may bring out a 2 to represent this group of 2's. And I also see 3 y's that I may bring out, 1 y to represent this group of y's. The only thing that didn't group up was this y, so that remains inside my radical with an index of 3. Go ahead and pause the video and try the next few on your own. For the first, you should have 3 rad 5, second 3 rad 3, third 5 rad 2, and down below you should have 2r, and then a radical with an index of 3 and a radicand of 3r squared. You should have 3w on the outside, and then in your radical of index 3, you should have 3w squared, and lastly, 3x squared on the outside, and with an index of 3, your radical has a radicand of 2x. Now, just as a reminder, some terms that we've already been using in this lesson. The index is the little number inside the check mark of your radical. The check mark itself is called the radical, and the number inside the radical is called the radicand. Another thing that I introduced you to in our last lesson was a rational exponent, or an exponent that is a fraction. What this means is that the denominator is the index of your radical. Whatever the numerator is, that number stays with the x. So to rewrite this as a radical, my denominator became the index, while my numerator remained with my x. You can kind of see there's a little invisible 1, and that came from the numerator of my exponent. So down below, we're going to go ahead and simplify each of the following. The best way to do this is by first rewriting it as a radical expression. So this denominator 2 is my new index of my radical, and inside my radicand is 16 to the power of the numerator, which is 1, or just 16. Here, the square root of 16 is 4, so this simplifies to just 4. To the right, the denominator becomes my index, so I have the square root of 9, or 9 to the first power. Square root of 9 is 3, so this simplifies to just 3. Down below, I'm going to apply this exponent to all of the bases inside the parentheses. This becomes 9 to the 1/2 power. And when I apply an exponent to another exponent, I multiply, so this becomes x to the 3rd power and y to the 6th power. All I need to simplify now is the 9 to the 1/2. 9 to the 1/2 is the square root, or radical with index 2, and inside I have a 9. X to the 3rd, y to the 6th. The square root of 9 is 3, as we saw above, so this reduces down to 3. X to the 3rd, y to the 6th. And that is the most simplified form of your radical. Go ahead and pause the video and try the remaining 3 on this slide on your own. You should have simplified the first to 7, the second to 5, and the last one to 7, x to the 4th, y to the 8th. On this next slide, I would like to practice writing each of these in radical form. We're not going to simplify them, we're just going to write them in radical form. So for this first one, we've already done very similar examples. This denominator of your exponent becomes the index of your radical, and the numerator remains with your base. So inside my radical, I have 8 to the first, which we may write as just 8. Now down below, again, this denominator becomes the index of your radical. So inside that check mark, I have a 2, and the numerator remains with the 9. So I have 9 to the 5th power. You may also bring this exponent out if you would like, and write it as the square root of 9, all raised to the 5th power. It does not matter if it's on the inside or on the outside, both of them mean the same thing. To the right on the top, that denominator becomes the index, so I have a 3 for my index, and 15 to the first as my radicand, or just 15. And down below, the 9, the denominator of my exponent, becomes the index of your radical, and the 6, the numerator, stays with that 23. So I have 23 to the 6th power, or, as we mentioned before, you may bring that exponent of 6 out to the outside of the radical. So instead of 23 to the 6th inside, I may raise that entire radical expression to the 6th power. Go ahead and pause the video and try the next 4 on your own. For the first, you should have the 4th root of 27. For the second, you may have written it either 3rd root of 41 squared or the 3rd root of 41 all squared. For the second two, you may have either of these options that I've written for you. Now we're going to simplify each of the following completely. So we're going to write it in radical form and then proceed to simplify it all the way down. So for this first one, I am going to rewrite it in radical form. That index of 3 comes from my denominator, and then I have 8 to the 5th power inside, or I can raise the entire radical to the 5th power. Again, it doesn't matter whether that 5 is inside on the 8 or outside of the radical completely. Now what I'm looking for are 3 numbers that multiply to 8 that are the same number. Here I have 3 2's that multiply to 8. So the cubed root of 8 is 2, and then I have 2 to the 5th power, which is 32. Now you may see that it was much easier to deal with that 5 on the outside later, rather than putting it here on the inside with the 8, and raising that 8 to the 5th power to obtain a very large number inside. Having a really large number inside makes it much more difficult to find the cubed root. Down here for 81, I'm going to rewrite this as a radical that has an index of 4 from the denominator, and my radicand is 81 to the 1st power, or just 81. Factoring this, 81 factors into 9 times 9, which reduces to 3 times 3 times 3 times 3. I'm looking for 4 numbers that group up. Here, all of my factors make a group of 4, so I take out 1 3 to represent that entire group, and I have nothing left inside or outside my radical. So my simplified form of this radical is 3. Down below, I'm going to rewrite this in radical form with an index of 2 from the denominator. My radicand is 4, and I'm raising it to the 5th power. But instead of writing that 5 on the inside, I'm going to raise everything to the 5th power. The square root of 4 is 2. Now raising that to the 5th power again gives me 32, as it did above. Go ahead and pause the video and try these next 6 on your own. All right, go ahead and check your answers. And we'll go ahead and move on. On this next slide, we are going to simplify these expressions completely by first simplifying each of the individual terms. So what I'm going to do is write each of these in radical form and simplify them, and then add the results together. So this becomes the square root of 64 plus the cubed root of 27. I need 2 numbers that multiply to 64. That number would be 8. I need 3 numbers that multiply to 27, and that is 3. I then add these together to get 11. So the most simplified form of this expression is 11. Go ahead and pause the video and try these next two on your own. For the first you should have 7, and the last you should have 13. For our last slide, we're going to simplify slightly more advanced expressions. To simplify this first piece, we need to remember that raising an exponent to a power tells us to multiply the exponents together. So 1/2 raised to the 4th, I multiply those two to get x to the 2nd power. I am now taking the square root of x to the 6th power. So I'm looking for how many groups of 2 can I make from x to the 6th. One way to do this would be to rewrite your x's out all the way. So instead of x to the 6th, I'm going to write x times x 6 times, and then make as many groups of 2 as I can. So I can make 1, 2, 3 groups of 2 from each of these x's. So I take out 1x from each of these groups to represent the groups themselves. So I may write this as x from the first group, an x from the second group, times an x from the third group. These 3 x's become x to the 3rd power. Now you may notice it might have been easier for me to just take this 6 and divide by that index of 2. You are more than welcome to do this, especially when the numbers are large. But since we've already gone through it this way, I'm going to go ahead and simplify. I have x to the 2nd times x to the 3rd. Since I'm multiplying two identical bases, I add the exponents to obtain x to the 5th power. To the right, I take this exponent on the outside and apply it on both the bases, multiplying by whatever exponent's already there. So instead of x to the 1/3, when I multiply by that new exponent of 3, I just get x to the 1st and y to the 3rd power. And now I'm going to simplify my radical by remembering the index is 2. As we saw in the previous example, I can take this exponent on x and simply divide it by the index to simplify that x. When I take 2 and divide it by 2, I get 1, so this becomes x to the 1st, and no x is left inside my radical. For my y to the 2nd, I may divide it by the index of 2 to obtain y to the 1st, with no y's left inside my radical. If these numbers do not divide perfectly and there's a remainder, then there will be terms left inside your radical. We'll talk about this in future lessons. For now, when I divided, there was no remainder, so everything came out of the radical, and I simplify from here. I can multiply my x's together to get x to the 2nd, and y to the 3rd times y to the 1st gives me y to the 4th power. Go ahead and pause the video and try the next and last example for the day on your own. You should have simplified this all down to x to the 12th times y to the 11th. Thanks so much for watching. I hope you guys enjoy the rest of your day.